All right, welcome back. So remember last time we talked about Anscombe's quartet. Here's another data set with 142 coordinate pairs. We can look at the summary statistics and should to determine the min, the max, the mean, get a sense of skew, standard deviation, the median. But when you plot this up, it presents a pattern. This is the datasaurus. It was invented by my DV crush, Alberto Cairo. And again, I just want to point out the importance of seeing the data as statistics and the data as a visual tool. So these folks here actually expanded on the idea of the datasaurus. They created 13 distinct data sets that all have the exact same mean for the x and the y, the same standard deviation for the x and the y out of all 13 data sets to 2 decimal places. But they plot up extremely differently, and this is different from Anscombe's quartet, which half of them had a positive correlation. You can see here that we've got all sorts of stuff going on. None of the same patterns and none of the same relationships at all. Including a dinosaur. All right, so the take-home message again is make both calculations, understand the data, and graphs. Study both. Each is going to help contribute to understanding. And if you haven't figured it out yet, I'm from Minnesota, and I apologize for my both. All right, so again, what and why is visualization? What is it and why do we do it? Finding the artificial memory that best supports our natural means of perception. This is Jacques Bertin. Visual representations of data to amplify cognition. Again, that amplifying cognition. And the purpose of visualization is insight, not pictures. It's not about being creative and making pictures. Don't do it for that sake. It's to see beyond what we can naturally perceive. So you're going to see some themes in these quotes, right? Amplifying cognition, increasing insight, supporting our ability to perceive. Jacques Bertin, just so you know, is a French statistician. Mackinlay had a long career, but now he works for Tableau, which is the software that we're going to be using this semester. So what does Bertin mean by artificial memory? He's talking about this. Try multiplying 36 by 84 in your head. I'll give you a minute. Are you even bothering? Okay, what if I told you you could use pencil and paper or write it down on a chalkboard? It's going to be a lot easier, right? Because we store all the intermediary information, you know, the 6 times the 4, write down the 4, carry the 2. We can store all that intermediary information on the paper, and we don't have to keep it in our heads. That's artificial memory, using paper. So a visualization is a way for us to store information outside of our minds and make it accessible through our eyes. Amplifying cognition means developing ways to solve problems better, faster, less mental effort, more accurately. Just basically making it easier to think and to understand. That seems like really good stuff, right? Right. Okay, the invention of charts. This very unassuming, mild-mannered Scottish engineer and political economist, William Playfair, was also a secret agent on behalf of Great Britain during their war with France. And you might find it interesting to know that he is also credited with the invention of many of the charts and graphs we use today, including time series plots, line graphs, and bar charts. He thought of charts as maps. He thought, hey, we use latitude and longitude to plot locations. What if we just swapped out latitude and longitude with other things like time and maybe levels of imports and exports? And this is one of the first plots that he made, was this time series line graph. In yellow, we have the line of imports to Denmark and Norway, and exports from Denmark and Norway. I just completely blanked out. I might be saying that. Exporting to Denmark and Norway and importing from Denmark and Norway. I'm not going to start this over. So what happens then is when we can see that visually, it's really clear to see that in the mid-1950s, these are decades, or sorry, 1750s, these are decades on the bottom, There was a switch, and the trade balance shifted to favor England. Genius. He used the same scaffolding, basically, as a map, and then employed methods of visual encoding. These are terms that we're going to kind of pick apart very soon and kind of repeat these ideas over and over this semester. All right, so why create visualizations? Really, it helps us ask better questions of our data, helps us understand, see patterns, discover things about the data, and then ask good questions. Helps us make decisions, see data in a broader context, expand our memories, support graphical calculations, find patterns, present arguments, or tell a story, or just plain old inspiring people, including ourselves. So 3 basic things though. We can use graphics to record information, to support our reasoning, and convey information to others. And I'm going to go through some of the kind of quintessential graphics. This is Florence Nightingale's coxcomb of Crimean war deaths. She served as a nurse in the Crimean War and saw a lot of needless deaths. These are called polar area diagrams. She came back to London compelled to convince Parliament to fund better facilities and treatments for British soldiers. She was devastated by what she saw during the war. The graphs show the number of deaths that occurred from, in blue, preventable diseases. Those were the results of wounds in red, and those deaths that were due to other causes in black. The colors measure out from the very center of each vertex. So we're talking about pi wedges that we are comparing areas for. And each vortex represents a year from April to March. So you can see by comparing areas from 1854 on the right to 1855 to 56 on the left, that the number of preventable diseases decreased greatly, but that the proportion of deaths by preventable diseases was, far outweighing all other deaths. She was, by the way, successful in convincing Parliament, and things changed drastically for the soldiers for the better. Okay, here's another one. Edward Tufte, who I mentioned last time, one of our data viz gurus, claims that this may well be the best statistical graphic ever drawn. And I'll have PDFs of this on our Canvas page. This is a graphic visualizing Napoleon's march on Moscow from 1812 to 1813. It's pretty incredible. There are 5 different variables being visualized that were encoded. Army size is being shown in the width of the tan and black lines. The tan is the march on Moscow and the black is the retreat. So the number of troops is being represented by the width of that line. We've also got location. There are city names. We also have latitude marked on here. I know it's really hard to see on this little screen. We've got dates. So as the march progressed, we've got direction. And then on the bottom, the temperature. The temperature dropped drastically and a lot of the soldiers froze to death on their way home. So we've got temperature on the line graph down below. Pretty incredible. I'm going to show you another version of this later on. They started out with 422,000 troops. Only 10,000 survived. It was quite a thing, but what a genius way to summarize an enormous chunk of history. We've been communicating and using graphics to record and reason for a long time. This is part of the prehistoric sun calendar drawn on the walls of Bulgaria's Magura Cave. It features 366 days. It's Europe's oldest known sun calendar. But check it out. It is 8,000 to 6,000 years BC. This is way back there, late Paleolithic. So impressive stuff. We've been doing this a long time, people. All right, Leonardo Da Vinci, mid 1400s to 1519. Brilliant man, brilliant mind, scientist, artist. He was the first artist to study the physical proportions of men, women, and children, and used these studies to determine the ideal human figure, quote unquote ideal. He felt that an artist must not know just the rules of perspective, but all the laws of nature. And he believed that the eye was the perfect instrument for learning these laws. And that the artist, of course, was the perfect person to illustrate them. But definitely data visualization in its truest sense. Galileo Galilei. This is coming definitely on the heels of Da Vinci's great work. He became very famous for a lot of things, but in particular this set of 6 little watercolors of the moon in its various phases. He used a telescope and in 1609 painted these first realistic depictions of the moon that were ever done. Aristotle taught before him that celestial bodies were perfectly smooth. And Galileo was able to argue convincingly that on the moon there did exist mountains and valleys, and he was the first person to be able to demonstrate that. Pretty awesome. Oh, and then this character, Eadweard Muybridge. He was a Brit who emigrated to New York at 20 and was almost killed when he was thrown from a stagecoach in 1860. It took him over a year to recover, and he was lucky to recover. But boy, did he have a wacky life after this. He is definitely best known for his photos of Yosemite. He was a photographer, but he got involved in a bet with the governor of California about whether or not a horse's hooves all left the ground at the same time when in a trot or a gallop. So he took this series of photographs and was the first person to do this kind of stop motion photography. But so here's the gossip on Muybridge. He married a woman in 1872, a woman who was 20 years younger than he was, and suspected that she was having an affair, and he shot and killed the man that he suspected. But here's the crazy part. He was acquitted for justifiable homicide, even though he pled insanity. It was a huge court case. Philip Glass even wrote an opera based on the court transcripts. He went on to have a really successful lecturing career, lectured to sellout audiences back in England, including the royal family in the 1880s. He had one heck of a life, let me tell you. Anyway, data visualization. Okay, Jon Snow, not from you know what, but the Jon Snow who was a doctor in London. This, if you haven't read this book, The Ghost Map, and I'm sure many of you have not even heard of it, but it is a wonky story about London back during the cholera epidemic. It's so interesting because at the time, miasma was what everyone knew to be the way that diseases were transmitted. Now it's an obsolete medical theory, but it dominated the period of Jon Snow's life, that basically poison air, diseases traveled through the air to make people sick. Cholera, chlamydia, Black Death, these were all caused by the air. They called it night air. But Jon Snow was kind of a polymath. He understood a lot of things, not just his area of expertise. And he knew the neighborhood, and he started tracking where people were getting sick and dying, and made these really interesting geographic bar graphs. Each bar represents deaths or cholera cases. And the density basically led him to suspect the water pump. And when the Broad Street well was closed, it turned out that cholera cleared up. So he used this map to hypothesize that it was, in fact, water. And he had to use these maps to convince other people to take him seriously, because that was just considered absolute nonsense, that diseases could come from, this liquid that gives us sustenance and is so refreshing. It was just crazy. Okay, here's a rather grim example. In 1986, we lost the Space Shuttle Challenger in a horrible disaster. It turns out we know now that these rubber O-rings, these gaskets, didn't do well in cold temperatures. But these are from the actual reports that NASA officials had to work with before launch. They had tested these things. They had tested O-rings. They had information about them, but the information looked like this. They were in big reports. Here's an actual data visualization, a graphic. It's reporting the temperature at the time of launch and the amount of damage done to the O-ring. Turning that data into a simple scatter plot where we have the temperature of the field joints at the time of launch and the extent of damage to the O-ring. There is, granted, a very small number of observation points here, but one could construe with perfect 2020 hindsight vision that there does seem to be a trend with colder temperatures relating to more damage. This is the temperature at the time of the launch of the Challenger. So given this information in hindsight and what we know about O-ring damage and O-ring susceptibility to cold now, this makes perfect sense. But it just goes to show that data visualization can be very important, right? Okay. Use the right visualizations to make good decisions.